Today we will be solving the problem on alternators. Draw the rotor pole and spider assembly of a 37 kVA 6-pole 3-phase alternator for the following data. So rating of the alternator is given: 37 kVA 6-pole 1000 rpm 3-phase alternator. The outside dia of the rotor is 240 mm. The diameter of the shaft is 45 mm. Spider across the phase dimension 130 mm. Pole width is 50 mm. Pole phase chord length is 91 mm. The height of the pole is 55 mm. Pole window height is 41 mm. And the field winding dimension adjacent to the pole is 10 mm by 33 mm. Poles are mounted on the spider by dovetail arrangement. So now for this, what we have to do is, as the number of poles is 6 and the details of the pole is given, first we have to draw the pole. So this is my pole. Okay. So we have to draw the pole. The height of the pole is 55, which is given in the problem. Pole height is 55 mm. The height of the window is 41 mm. So this is the height of the window. And this is my pole arc. So this is 41, 55 mm. Width of the pole is 50 mm. This is the width of the pole, 50 mm. These are the main dimension. Pole phase chord length is 91 mm. This is the pole phase chord length is 91 mm. So all these dimensions you have to know. And the dimensions of the field winding 10 mm by 33 mm. So this is the field winding. This is 10 mm, this is 33 mm. So first we will draw a single pole separately using AutoCAD software. After drawing the pole, we will draw the rotor pole and the spider assembly. It is given the shaft diameter is 45 mm. So draw the shaft. Next is 130 mm is the spider across the phase dimension. This is the spider dimension. This entire portion is called as the spider. So this portion is called as the spider. Then overall dimensions is 240. The outside diameter of the rotor is 240. So I will be telling you how to draw the pole initially using AutoCAD. First, open the AutoCAD software, set the units, limits and Z enter, A enter. Now I will draw the pole. So this is 50, this is 75. Overall is height is 41, window height is 41, overall height of the pole is 55. So initially I will take a line and switch on the ortho, draw a line of 50. After drawing a line of 50, height is 41. Draw a reference line. Drawing a reference line. This is my reference line. So this dimension is 50. Now from here the height is 41. Whole window height is 41. Draw a line of. From here, draw a line of 41. Line of 41. Similarly, from this side, draw a line of 41. So we have drawn two lines of 41. After drawing the line of 41, you have to extend your draw the window of 33 by 10. Okay. Field winding of 33 by 10. So field winding dimension is 33 by 10. So what I am going to do here is, this is 41. Go for the dimension. Go to dimension style, modify, as 8, position 0, this is 41. So I want 33 by 10. So go for a rectangle, specify the point. I'm giving the dimensions, D enter. So what is the length? 10 enter. What is the width? 33 enter. So I'm drawing a rectangle of 10 by 33. So this rectangle I'm drawing 10 by 33. This rectangle of 10 by 33. So here it is 41. So 41 minus 33. Calculate. 41 minus 33 is 8. So from here leave 4 mm, from here leave 4 mm. Okay. So I'll change the color for my reference. Take a line. Draw a line of 4. Okay. Similarly, on this side also draw a line of 4. So how I have taken this is entire 41. This is 33. 41 minus 33 is 8. So here 4 mm I have to leave above, below I have to leave 4 mm. Now I'll take this, go for the copy selection. I'll select this end as the base point and put it exactly at the 4 mm line. Similarly, select this, copy selection, select this as the base point, place it exactly below the 4 mm reference line. See, you can observe here how I am placing that. So now I will delete the red line, reference line, which I put of 4 mm. Now exactly I'll get this as 33 and this will be 10. So 33 by 10. You can go for the hatching of the field. Go for the hatching. Select any pattern. Add pick points. Press enter. So these are the field windings. After drawing the field windings, now I have to draw the so overall should be 91. So this is 50. I'll draw one more line of 91 reference line. So draw draw a line of 91 mm. Select the midpoint, place it exactly at the midpoint of this. So this is my 91 mm line. So what is happening here? Project it. If you are getting confused, just delete the dimensions. Now extend this. So overall is 91. I've extended the 91. Then draw a 2 mm line. Delete this. You can put a reference line here. You can delete. So overall will be 91. Now draw a line of 2 mm on both the sides. So draw a line of 2 mm. Total height will be 45. The height should be 45. From here, 55. Enter. So it is 55. What you can do is send this. Send this line, draw a line. Now go for the 3-point arc. Select at the end of the 2 mm line, select the midpoint of this line, and select the end of the 2 mm line. Now you can delete this reference line. These two lines can be deleted. This is how I am going to draw the So this completes the pole. Delete all the reference lines. All the reference lines are deleted. Now you have to draw this portion. For that, what you can do is join this line from the midpoint, change the color to red. From the midpoint, this side you can take a line of 2 mm and from the midpoint you can take a line of 2 mm. So both these sides we have taken a line of 2 mm. So now switch on the polar. Draw a slanted line. Same line you can go for the mirror option, or you can note down the angle and select the objects. Enter. Mirroring it. Now you can delete these red color lines. Make it black. Now go for the trim option. You have to place the circles. Take a circle, click here. You can specify the diameter or randomly you can take. I'll take D enter, 5 enter. I'll take 5 mm dia. Take a single circle, copy selection, select the base point, place it somewhere 1, 2, 3, 4 and 5. 1, 2, 3 and 4. So this completes the entire pole. So this pole has been completed. So now what I have to do, I have to draw a shaft of 45 mm dia, and the overall outer diameter of the rotor is 240 mm. So take a circle, take the center, D enter, 240 enter, draw a circle of 240. Move the circle, is it here? So this is a circle of 240 mm diameter, and again another circle for the shaft with the same center, D enter, diameter is 45 mm. So this is my shaft. The shaft. So what is the height? 130 mm. So spider cross section across the face dimension is 130 mm. So draw a line of 130 mm. So I should draw a line of 130 mm. Draw a line of 130 mm. Switch on the ortho. Draw a line of 130 mm. Place it exactly at the center. So this is my 130. So now you have to place your pole exactly at the center. For that, what I am doing is I'll join a reference line here. And select the entire pole. For copy selection, base point is this, and I have to place it exactly at the center. So now I have placed the single pole. Delete the reference line. Delete this reference line. So we have placed the single pole. So we require 6 poles. So now I'll go for the polar array. Type array in the command prompt. Select array classic. Go for the polar array. Total number of items 6. Angle to fill 360. Select the center point as the center of the circle. Go for select objects. Select the entire pole. Everything is selected. Press enter. Press OK. Now you can give the main dimensions. Know the dimensions. So these are the main dimensions. Similarly, give the dimensions for this. Dimension, diameter. Dimension, linear, 130. One is 240. Dimension. Any one of these circles. Now you can delete this. This completes the problem. So this is how you have to do the pole. Then you have to make a polar array. So here the dimensions are very important. What are given dimensions are there? You have to take the dimensions. Accordingly, you have to draw the drawing in AutoCAD. So we can save this. So this completes the problem.